Hello and welcome everyone to my channel Code with Ease. Today we are going to start with the recursion primer series. So the objective of this series is going to be, so even before we start doing complex problems and understand concepts related to dynamic programming or memorization or backtracking, it's very important to understand the fundamentals of recursion and not just the theoretical concepts of recursion but to do it in practice. So the goal over here is we have to develop a thought process using which we can break down a bigger problem into smaller sub-problems and thus create this thought process of solving something using the recursive strategy. And as and when we start building on these concepts from the scratch, then we will be able to solve any complex problem involving any of the algorithms, maybe DP, backtracking or whatever. If the fundamentals of recursion are strong enough, we will be able to solve all of these complex problems very easily. So that is the whole objective of having this playlist. So in this, we are going to first talk about what recursion is, a bit of theory of recursion, and then we are going to start slowly from the very basics. So we are going to do few questions which will help us in building the recursive thought process. Like given a question, if we solve it using for loop, how can we solve it using recursion also? So all of that we are going to do as part of this series. So I hope you guys would be excited, and please stay tuned and do subscribe to my channel as well. Now, starting with the main thing, what is recursion? So recursion, this word comes from a word called recur. So recur means anything that repeats. I think the primary idea behind recursion with which we have studied mostly is a function, calling function is called recursion, which in a sense is okay. It's something like that, but it is not simply a function calling function and so on. A function calling another function, or maybe a function calling the same function, but that is done with the goal of solving a bigger problems, or maybe for breaking down a bigger problem into smaller subproblems, so that with every function call that is happening recursively, every function call is trying to break that big problem into smaller chunks and try to solve those smaller chunks. And altogether, when those smaller chunks are combined, when the solution of the smaller chunks are combined, then we are able to achieve our actual solution. So the understanding behind this should be a function calling function with the aim of breaking down a bigger problem into smaller subproblems, thus solving each smaller subproblem, which will help us to achieve the required result. And the beauty of doing this is, so it reduces the number of lines of code drastically, which we'll be seeing in many of the examples that we'll be doing. So that's about it. Since it requires very few number of lines of code, the code becomes in itself very readable and crisp and very easy to understand. So that is the reason why we should be using recursion. Okay, so talking about the properties, like we mentioned, there is this function which is being called again and again. But if that function is being called again and again with different parameters or whatever, there must be a point where we have to tell it to stop. Okay, let's forget recursion for now. Even if it is a for loop, if the for loop keeps on happening, if it keeps on running without some condition in place, it will lead to an infinite loop. Similarly, in recursion, we also have to give it some condition where we will say that it has to stop. But then, since we're calling the method only again and again and we don't know what is happening inside the method, how will we ask it to stop? This is where this concept of base case comes into picture. So whenever the method is being called, inside the method, at the very beginning, we have this base condition. In that base condition, we specify some condition which, when true, the recursion will stop over there. So that is the very important property of a recursion. To happen successfully, we have to give a base condition. So we all know about this website called Stack Overflow. This has actually come in from a concept related to recursion only. If the function is being called again and again, and let's say we do not have a base case, means we are not telling the recursion to stop, just as in case of loops, it will cause an infinite scenario. But then we have to understand that when recursion is happening, when the functions are being called, it is happening via a data structure called stack. wherein every function call keeps on piling up on this data structure, and stack itself follows the last in first out. So whatever method call is at the top of the stack, that is being returned first, and so on. So if, let's say, we do not have a base case and we are calling the method again and again, so in the absence of the base case, so since the stack even has certain limits, memory constraints it has, it will keep on piling up, and after some time it will say the stack has overflowed. It cannot take in any more function calls. So this leads to a condition called stack overflow. Because of that reason, it is imperative to have a base case in recursion. And lastly, we are just trying to sum up this today's session by doing a quick comparison of recursion and iteration. So iteration, like I was talking about for loops, anything that is happening again and again using the loops, that is iteration. And recursion, as we have discussed, the methods are being called again and again in order to solve the bigger problem by solving it, by breaking it down into smaller chunks. So the first thing is recursion will terminate when the base case is true, and in case of loops or in iteration, whenever the condition, the while loop condition or the for loop condition is false, it will stop over there. Recursion deals with functions and iteration deals with loops. And recursion requires some extra space, like I mentioned, the stack data structure it will require in order to have all the calls being piled up on that, which is why it is kind of requiring an extra space. In case of loops, even though we have variables and everything occupying the memory, but that is not significant as in terms of whatever is being occupied by recursion. Code size, like we mentioned earlier also, recursion makes the code more readable and elegant and crisp, but whenever you're trying to solve the same problem using iteration, using loops, the same problem we have to write it using more number of lines of code. There's more logic into it, which is why the overall the code size becomes bigger in case of iteration. But in recursion, even with 2-3 lines, we can achieve, logic which is equivalent to 10 to 15 lines of code in iteration. So that is the difference between recursion and iteration. So with that, I'm concluding today's video. I hope you guys have enjoyed the primer and would be looking forward to the recursion problems that we will be solving from scratch. Thank you so much for watching this video, and please don't forget to subscribe to this channel in order to be updated on this recursion series that we are starting shortly. Thank you again. Thank you so much for watching.